Hey, Professor.
Hey, how's it going?
How you doing?
I'm good. All right, so everybody in here. All right. Good evening, everyone. Good evening. Hope all is well. Just waiting for a few people to get all the way connected, and we'll get rolling. Mr. Corey, you over there grubbing, man. You making everybody hungry, man. Oh man, what's that? Cashews, Peter?
It's hummus.
Oh, okay. Okay, cool. Getting a healthy eating on. Okay, I hear you.
Hello,
Hey, how's it going?
it's going well.
That's good. That's good. All right. So hope everybody's doing great. Hope everybody had a great week. Consider, last time I saw you was last Tuesday. I only see you guys once a week. I think some of y'all love that, right? So let's see. Help me out because I have a whole bunch of classes. Did we even get into chapter 3 in this class? I don't remember we even started chapter 3. I see heads nodding.
No, we did 1 and 2.
Okay. All right, cool. Just wanted to be sure before I did anything. Okay, so let's go ahead and get into chapter 3. And then if anybody have any, did anybody have any general questions? Everybody good with this? Everybody in my math lab? Everybody flowing? Everybody all right? All right, good. I think that's okay. Cool. If you have any questions, of course, feel free to ask.
Yeah, what do those questions do?
Talking about definitions?
Yeah.
And get it to me before the end of the week. I mean,
Okay.
it's nothing major, but
Friday, September 3rd was said.
That's what I said, September 3rd. Okay, cool. Thank you. All right, so I got 135. All right, so the title of our section 3.1 anyway is summaries for symmetric distributions. You don't have to copy what's in red. That's just a note to myself. I'm gonna go to another set of notes in order to get what I want to give to you guys, but right here is our title that you guys have for 3.1. Give you a chance to write it down and then we'll go. All right, so I got mean, standard deviation, and variance. Okay, so let's go to 245. All right, so this is not your title, but these are your notes. So looking at the mean first, remember we just talked about the title that you guys have. So we're looking at the mean first. The mean in statistics is another word for average. And so the way we would calculate the average is we add up all the data values, divide by the number of data values. Now over here in the green is a statement that's in your book. So you do want to go ahead and make sure you have that because I think my math lab will ask you different things like that. So I try to point out different sentences that my math lab emphasized in the homework. So it says it is located at the balancing point of a distribution of data. Somebody trying to get in. There we go. It is also one representation of a typical value of a variable in this section. I mean, in your data values, data set. One representation of a typical value of your data set. All right. So
I have a question. What do you mean by divide? What do you mean by divide? Like when I was doing the homework, I was getting a little confused. Like I was getting it, but then I was getting confused. So like in the graphs, like how it said men, women, and others, and who had older siblings and who didn't have older siblings, right?
Mhm.
So when you figure out, it gives you the little blocks to figure out, okay, the number of women who had older siblings, and then you had to fill in those blocks. But is that what you're talking about? Like you add all those across or all those down, and then you divide by what?
I need to see what you're talking about, because that problem, now was that problem in chapter 2 or chapter 3? Because if it was in chapter 2, that was probably something that was in reference to that graph or that data set, and it has specific, characteristics that were going on. So I had to look at, if you can find that problem.
I think it's chapter 1.3.
Yeah, I was gonna say it's chapter 1.
Okay. Yeah. Well, then that's not talking about what we're talking about here. So that has something
Okay.
to do with the characteristics of that data set that they gave you. And so if you can find that problem, but after we finish the lecture, I can go, we can talk about it and everything like that. So if not, we can, go look for it, see if we can find it before we close out. So in the red is just an example of how you would find the mean. If my data set was 1, 2, 3, 4, 5, I would add up those numbers, and then I would divide by the number 5, because I have 5 numbers. And then 15 divided by 5 is 3. So the average or the mean of that data set would be 3. Are we still copying? Can I scroll up or think we good? Okay, cool. Next value is our median. You can think about middle. So we will list all our data values from least to greatest. So notice I put a note, say, don't forget that. A lot of people will, if they mess up anything, they will, forget to put your data values from least to greatest. And if the number of data values is odd, you take the middle value. If the number of data values is even, we would take the mean of the 2 middle values. So in other words, you take the 2 middle values that you have, add them together and divide by 2. If you have an even number of data values, you don't have a legitimate middle number. So that's how you would find a middle value, a middle number. All right. So we have 2 data sets. So we can explore both situations. So data set 1, I have the numbers 1, 2, 3, 4, 5. That's an odd number of data values. So that means we have a legit middle number, and that middle number is 3. So that would be our median. Now in the second data set, we have 1, 2, 3, 4, 5, 6. So we have 6 numbers. That's an even number of data values. That means we don't have a legitimate middle number. So what we would do is take the 2 middle values. Let me see if I can magnify this. Take the 2 middle values, which is 3 and 4, add them together and divide by 2. That'll give us 3.5. And notice 3.5 is in between 3 and 4. So that splits our data, in half. That gives us our middle value to split our data in half. All right. So, and the green says the median separate the data set into halves. So I mentioned that already. But also over here in the red is another statement. I mean, orange is another statement from out of your book. It says it also represents a typical value in the data set. So, you'll start to see that your mean or your median is just different values like this can represent a typical value in your data set, and different ones will be used according to different situations that you have. All right. Are we good to scroll up? Let's go. If I scroll up and somebody's still writing, always feel free to let me know.
I'm still writing.
Oh, go ahead. Okay. All right.
I'm up to the green. I'm almost done.
Okay. Okay, cool. Not a problem. Not a problem. So next one is the mode. You think about the most, it's the data value that appears the most frequently. It is possible to not have a mode. It's also possible to have more than one mode. So if you have two modes, that's considered bimodal. More than two is considered multimodal. All right, still see copying, okay. Think I got it too small. All right, scrolling up a little. Here's just an example of the mode, finding the mode. So if my data set was 12789675297651347, the data value that appears the most is the number 7. So that will be my mode.
Professor, does that say out, Outliers?
Yes, outliers. Yep.
Okay.
Yep, you got it. So everybody done with the red? Can I scroll up? Hit a button. All right, there we go. So going to the statement that she just referenced, a summary of data is said to be resistant if outliers, so outliers are very extreme values in reference to the data set, if outliers do not affect it. So data value or data set is said to be resistant if outliers does not affect it.
Can you explain that a little more?
Oh yeah, I'm just waiting for people to copy. I got examples down bottom.
Oh, okay, I'm sorry.
Oh, you're fine. Just don't want to scroll up too fast and people trying to get to it. All right. So looking at our data set down here, we have going back to 1 through 1, 2, 3, 4, 5. We already found that the mean was 3 and the median was 3. You know, the mean is your average, so you add them up together, divide by 5, that was 3. And then our middle value is the median, so that's 3. Okay, so now, and if I can go up further, about done with the black right here. So now if we look at that same data set, but let that 5 be now 500. So in other words, that 500 is an outlier. If I were to add them together and divide by 5, my average is now 102. But my median is still 3. So the presence of the outlier did not affect the median. And so that's what it means for a data summary. And you know, your median, your mean, there's summaries of data. When a data summary is not affected by an outlier. And so
Why is 3 the median, the mean and the median again, please?
right here,
Yeah.
that goes back to now the median is just the middle number. Your middle number is your median. Now the mean is when you add up your data values and then divide by the number of data values that you have. So remember our first example was this, when we added up 1, 2, 3, or 5, we had 15, then divided by 5, and it gave us 3. So I was just
So even though there's only 5 numbers and it still would be odd, it's still the middle number.
yeah.
Like
so,
I'm looking at it as a whole. Like, am I looking at it wrong? Because I'm looking at it like, okay, 3 would be the middle number if there were 6 digits. But you're saying no, 3 is the middle number just because it's the middle number? Like,
now, if you say if there were 6 numbers, then you wouldn't have them. If there were 6 here, then
You wouldn't have a median.
you wouldn't have a legit middle number.
I'm
Because
sorry, sir. What did you say?
if you had 6, you said if you had 6, then you would have a middle number. So you wouldn't really have a middle number if you have 6 digits, 6 numbers, 1, 2, 3, 4, 5, 6, because you have an even number of data values. So there's no middle number right here. You have 3 on the left and 3 on the right.
So basically the data set has to be an odd number, an odd set.
Well,
That's what I was gonna ask.
in order for you to pick out just the middle value. Now, if you
Okay.
have an even number, what you have to do is take the 2 middle numbers, add them together and divide by 2, and then that'll give you the median. So if I had 1, 2, 3, 4, 5, 6, my median would actually be 3.5. So that goes back to what we did right here. That's what happened right here. We had the data set of 1, 2, 3, 4, 5. And so our middle numbers is 3. But when we had the data set of 1, 2, 3, 4, 5, 6, there was not a legit middle number. So we had to take 3 and 4, add them together and divide by 2. And that gave us our middle value.
It makes sense when you're saying it, but I swear if I see it, I'm probably gonna lose my mind, but it's okay.
But as of right now, it's okay though. Is that what you said?
Yeah, as of right now, because the way that you say it, like, because you're saying if there was 6 digits, chill out. if there was 6 digits, quiet, if there was 6 digits, you're saying we would have to add the 3 and the 4 together
Mhm.
and then divide it by those two numbers because it's an even amount of numbers. But since
Mhm.
there's an odd amount of numbers, 3 is the median, is the middle number,
Mhm.
and then that would be the median.
Mhm.
Okay.
Yep.
Question.
Is that for all odd sets?
Yes.
It's the
For
same for
all
all.
odds, you will always have a middle number because it's an odd number of data values. Just like, excuse me, just like if you had 11 numbers, you will have a middle number. But if you have 10 numbers, you won't have a middle number because you have 5 and
then you would-
5.
So then you would take those two middle numbers if you had 10 and add them together and then divide by 2 again
Right.
and then go, okay,
Mm-hmm. Mm-hmm.
okay.
I have a
Thank you.
question.
Not a problem. Mr. Corey.
Yeah, so say the numbers are all jumbled up. Do you have to organize them chronologically and then figure it out?
Yes, sir. That's that.
Okay.
That's that step that. Oh, I still have my eraser on. My fault. That's that step I said. Don't forget. List all your data values from least to greatest, and then you go from
got you.
there. Mm-hmm.
Thanks, Corey.
Thank you.
All right. So, all right. So going back here, just to make sure we're clear on this being resistant. Hold on, let me erase this because it's not supposed to be here. All right, so going back to being resistant to outliers. If I were to make this a 500 instead of 5, add them together, divide by 5, I get 102, wherein before the mean was 3. So the outlier affected the mean, but it did not affect the median. Remember, the median is just the middle number.
Just the middle, okay.
It's just the middle number. So this means that the median is resistant to outliers. If an outlier appears, it does not have to affect the median, but it will affect the mean. And I ran off the screen a little bit. So that green statement, it says it is a good choice for a measure of the center if the data contains outlier. So if you have outliers, then you use the median to do your summary. All right, can we go to the next thing? Good, good.
Sorry, I have one question. So is it possible for something to be unresistant? Is there,
Well, the mean is not resistant because the outlier did affect the mean. So you can look at it that way, if that's what you're saying. So it's basically, will the outlier affect it or will the outlier not affect it? So the outlier did affect our mean. So remember, our mean did change to 102. So
oh, okay, gotcha. So wouldn't all outliers make the data become unresistant?
well, it's not about the data, it's about the summary. Remember, the statement
The
was
summary, right?
summary of data. So the data set most definitely will change because you're adding a new value to the data set. But these things that we are evaluating are summaries of data. So your mean, your median, they're all considered summaries of data. They summarize your data. And
So yeah, so wouldn't an outlier affect the mean and mean, or at least the mean every single time?
yes.
Okay,
Yes.
all right.
Mhm. Yeah, so that's why our point with this was it will not necessarily affect the median though. And so that's what we were just trying to show, that the median is resistant to outliers, not the mean though. You're right with that. The mean will always change. Yeah.
Okay,
Mhm.
gotcha. Thank you.
Yep, not a problem. All right, don't copy anything yet. Don't copy anything yet. We have to go to, let me make sure. Yep, standard deviation variance. So is that all in one, two? Okay, all right. So where it go, where it go? All right. Not the title, but we start right here at dispersion. Dispersion is the degree to which the data is spread out. Still in 3-1, but this is the last few things out of 3-1.
You said this is 3-1, not 3-2?
Yes, this is still 3-1. Just
Okay, thank you.
mhm. So dispersion is the degree to which the data is spread out. The green statement, the distance spanned by the entire data set is going to be your range. So I think that was another statement that came out of you guys' book. So range is easy calculation. You just take the largest data value, then subtract your smallest data value. All right, so if our data set is 1, 2, 3, 4, 5, do 5 minus 1, and our range would be 4. So once again, we're talking about different things we can use to summarize our data, to be able to compare data sets. You know, so this 4 represents the distance span by the entire data set. All right, oh, still C copying, okay. All right, so next thing, standard deviation. Measures how far a data value is from the mean. Variance is the standard deviation squared. And it's just another thing or another way we use to measure the spread of data.
Professor, we're still in 3.1, right?
Yes, we're closing it out with these last few, these terms right here.
Awesome, thank you.
Not a problem. All right, scrolling up a little. So if I'm scrolling up too far, let me know. So you guys are not held responsible for actually knowing how to do the standard deviation and variance formula, but you are held responsible for finding something that can help you to calculate it. So I'll show you an example of one in a second. But notice I have here in the red, find an app, calculator website, something to that nature that will help you calculate the standard deviation and the variance. So we'll talk about the application, in a few, but the main thing is you need something that's going to be reliable that will calculate it for you. So one website that's reliable, easycalculation.com.
You said easycalculation.com?
Yeah, I got it right here on the screen. Yep, in the blue.
Oh, okay, sorry.
Yep. No, you're fine. You're fine. No. I just, and so like I said, I'll show you that one in a second, but you don't have to use that, but I'm also not asking you to purchase anything new. So everything I'm talking about right here, it's all free, find free apps and all this stuff. So. All right, so using this as an example, we have 62, 88, 77, 68. And so I'm going to go to the website, throw those values in the website, and get out my standard deviation and my variance. All right, can we go to another page? No, still see copy.
You want it always rounded up to the 10th place, correct?
My math lab will let you know. So make sure you hold true to those directions, because in one, and I think they do that just to make sure you're paying attention. One problem they'll say round to the tens, then the next problem they'll say round to the hundreds, and then you'll see the thousand, three. So yeah, just hold true to whatever they say in my math lab.
And
I
then
was just wondering because your notes are rounded to the 10th.
Yeah, I did that because of the example in the book. But I do know in my math lab, they will ask you, different place values in your homework. So, yep. Did I hear somebody else saying something? Oh, okay. All right. So let's go to internet real quick. Let's go to Google. So if I wanted to, and let me make sure you guys are seeing my right screen. Okay, cool. So if I wanted to find something that can calculate standard deviation, so you see I even got it already here, standard deviation, easy calculation. And notice the first one that comes up, standard deviation, easy calculation. So if I'm trying to find something, I put what I'm trying to find and then easy calculation. And easycalculation.com is the first one. And then whichever one you use or whatever you use, make sure you hold true to the directions. So this one says separate by comma. I've seen ones say separate by space, others separate by semicolon, So this one says separate by comma. So I think the first 62, 88, 77, 68, 88.
88, 77, 68.
Thank you. So calculate, and there you go. So there's 11.3. And this one give you a more accurate variance because it actually uses the formula. But if you were to square 11.3, that would be the value that you have in your notes. But either one of them should work as far as my math lab is concerned, because they give you a plus or minus on your answers. So notice how you get two different ones. You have a sample standard deviation, a sample variance. Then you have a population. standard deviation and population variance. So we'll talk about the difference in a second, but just showing you that this one gives you both. This is the population, and this other one up here that doesn't say population is your sample. So we'll talk about it in a second. So is everybody good with, let me see, go back. Everybody good with that? Questions on it? All right, I'm going to close that out because it makes my stuff move slow sometimes. Let's go back to the notes. Oh yeah, we need to know this. So notation. I'm not sure if this is in 3.1 or 3.2, but it just matters because you need to know it. Whenever you're dealing with statistics, excuse me, your notation can be different or will be different according to whether you're dealing with the population versus your sample. I think I'm trying to lose my voice a little bit. Your population versus your sample. So what do we mean by that? For example, TCC student body, the whole student body, everybody enrolled at TCC will be the population. This class will be an example of the sample, a sample of that student body, just like sampling food, you know, a piece of it. So that's your sample. So your X will always be your data value. Whenever you see X, that always represents your data value. This is Greek letter mu, and that represents the population mean or the population average. This is Greek letter sigma, and that's lowercase sigma. That represents the population standard deviation. Over here, I was just showing you what capital sigma looks like. Most of you probably seen capital sigma before. Somewhere you've seen it, but it means summation. It means adding up all of your values. So or adding up your data values. So that's what Greek letter sigma represents for us. But here we have lowercase sigma and then lowercase sigma squared. Remember, your standard deviation squared is your variance. Capital N will always be your population size of your population. All right, under capital N, we have X bar. Any letter with a bar over it will be that letter bar. So just like I wrote right here, Y bar. Y, that's Y with the bar over it. But X bar is your sample mean. Regular lowercase letter S is our sample standard deviation. S squared is our sample variance. And then N, lowercase n is your sample size. So in that example that I just gave, when you have 4 values, more than likely that was a sample. You know, your population is expected to be very large, and a sample is just a certain amount of number outside of, pulled out of the population. So those 4 data values more than likely was a sample. Hard to believe that 4 data values would actually be the population. All right, questions. Let's see. Yep.
I have a question for you.
Mm-hmm.
What does that say with the Y with the line above it equals Y? What's that word beside that?
Y bar.
Oh, bar. All right.
Mm-hmm. Yep. I was just saying that
Y
any.
minus bar.
No, Just Y
Just Y
dash
bar?
bar. Y
Y
dash
dash
bar. Uh-huh. Just saying that any letter with the bar over it just is that letter bar. Just like
Oh,
we
okay, I
have here
got you.
X bar. So that would be.
Oh,
I got you.
Yep. All right, so I believe we're ready to look at 3-2, 155. Yep. So 3.2, what's unusual? The empirical rule and z-scores. Once again, don't copy that. That's just notes for me. About to switch to another sheet.
Does that say Z scores?
Yep. Z-scores. Yep. All right, so let's go there. All right, so the empirical rule. So shorthanded, that's APP approximately. It's approximately 68% of the data is within one standard deviation, one SD standard deviation of the mean. Approximately 95% of the data is within two standard deviations of the mean. And then approximately 99.7% of the data is within three standard deviations of the mean. Of course, we're gonna talk about what that actually means in a second, but give you a chance to write that down.
I have a question. Is that approximately 99.71? Is that 35% within 35 of the mean, or just, is that 3?
I think that says
Yep.
3
Y'all didn't tell
standard.
me. Oh, yeah,
SD.
yeah,
Oh, that's
y'all didn't.
3 SD.
Yeah, I was over
standard.
here talking with my mute on. Y'all didn't say nothing. I was talking. So yeah, that's 3 SD, 2 SD, 1 SD. So one standard
Standard.
deviation, 2 standard deviation, 3 standard deviation. Yeah.
Okay. Thank you.
Yeah, not a problem. All right, so this chart represents those percentages. So we'll use it in a second, but these percentages do not change These percentages do not change. They're the ones that hold true to the empirical rule, 68%, 95%, 99.7%. These numbers down here will change according to what information we have. Your mean and your standard deviation will dictate what goes down bottom, but those percentages do not change. Notice your mean is in the middle, and everything, remember I mentioned before when we were looking at this bell-shaped curve, everything is reflected about the mean. So 50% of your data is to the right of the mean, 50% of your data is to the left of your mean. So if you were to add up these values, that's 50%, add up these values, that's 50%. And of course, 50 plus 50 is 100. So all of it represents 100%. 100% of your data, and it's about the distribution of your data. So if you look at the blue, if you add a standard deviation and subtract the standard deviation, in other words, go one standard deviation out, that's 68% of your data, 34 and 34. And if you were to add another one and subtract another one, go two standard deviations out. In other words, if you add, I still have my eraser on, I keep forgetting that. Add up all of these, that'll give you 95% of your data. And then if you were to go one more out, add and subtracting, and you add up all of these percentages, that give you 99.7. And then what's left here on the tails is just 0.3, which gives you 100%. So
Let's say 0.01%. 1.5. Okay.
Yeah. Are you talking about over here in the tail down here?
Yeah.
Yep.
Yeah.
0.15%. Yep. Make it a little larger. I'll show you how, these percentages work with this and all that stuff like that. Miss Caskey, sorry, I just saw your email. So you're in here now, so I guess we're good to go.
Yeah, you're good. My laptop wasn't working, so I had to go through my phone to get on here. So I'm a little late,
Gotcha.
but I'll just watch the video if you post that up later.
Gotcha. No problem. It's not a problem. But like I say, I didn't see, if I saw it, I would have responded to you.
Yeah, no, you're good. You're good.
And so what days are your office hours for like help?
Email me and we can make it happen. It might be better that we, because it depends on our time. We can match it up, because even if it's a
Right.
Friday evening, Saturday morning, it just depends on what's going on with you.
Okay.
I'm kind of flexible, so I just kind of left it out in the air so we can match up individually with schedules. So
Yeah, like Mondays and Fridays would be good for me because I'm like full-time. I'm
mhm.
5 classes and work full-time, so Monday and Friday was good.
Gotcha. Because see, if I really set hours, I'm not going to set it on a Friday. You know what I mean? So I might as well just go ahead and just see what you guys
Right,
want to do. You know what I mean?
listen, trust me, I don't want to be mean with you on a Friday either, so I mean.
And look, and no love lost either.
Right.
But I know that, sometimes that's the only thing we got. So, that's why, I'm most definitely
Right.
flexible for it. You know what I mean? So,
All right, I appreciate it, thank you.
yeah, no problem.
Are you on campus on the weekend at all?
No, unfortunately, no. Not as far as on campus on the weekend, but throughout the week, I can make moves on that. But throughout the weekend, it was kind of tough. Yeah.
Would it be the Chesapeake location or would it be the
Uh,
Norfolk,
Portsmouth.
Portsmouth? Oh, wow, okay.
But we can make an attempt to do it through Zoom and then see
Okay.
about that might be easiest.
Okay,
So, but we'll talk. We just shoot me that email and then we'll
Okay.
talk. Yeah.
all right, sweet, thank you.
Mhm. All right, guys. So let's put an example to this. So it says the mean IQ score of students enrolled at University A, just some random university, is 100 and standard deviation is 16.1. So A says determine, as is the DET, determine the percentage of students who have IQ scores within 3 standard deviations of the mean, according to the empirical rule. Determine the percentage of students who have scores between 67.8 and 132.2. And then C, determine the percentage of students who have scores above 132.2. So I'll give you a chance to write that down, and then we'll look at these questions.
Determine.
Yep, DET is determined. Mhm. Or determine, determine the percentage of students. Yep.
Okay, good question. What is the word right after this last sentence on the first question? Students have a IQ. Is that scores?
Yeah, that's my sloppy scores.
Okay. All right, thank you.
Not a problem, not a problem.
Professor, on letter C, is that determine the percentage?
Yes.
Okay, thank you.
All right, scroll up a little. Guess I'll wait because I don't want to get started. People still writing down the problem. All right, so when it comes to any problem, it's always good to write down the given pieces of information first. So first thing I establish is that our mean, they gave us our mean is 100, standard deviation 16.1. Now we are talking about students taking IQ scores. So I just called it our population. But remember, if we were talking about, and all I was doing right here is emphasizing, symbolism. If it was our sample, our mean would be X bar. If it was our, if it was our sample for our standard deviation, it would be lowercase s. So that's all I was emphasizing here. All right, so now for the first one, we don't really need to do any work. We really can just lean on the empirical rule, but I want to go ahead and look at filling out this chart. So if you notice, you have your mean in the middle, you have the right side of your mean, and then the left side of your mean. All right. So if you notice, the right side is just adding a standard deviation 3 times. And so that's what I did right here. You have 100 as our mean, add 1 standard deviation, that's 16.1. Add another standard deviation would be 132.2, and then add a third standard deviation would be 148.3. So that's 1, 2, and 3 standard deviations to the right. All right.
How did you get those numbers?
You just take your mean and then
Uh-huh.
add the standard deviation. Now, are you talking about how did I get the mean and the standard deviation, or are you talking about how did I get these numbers?
How'd you get those numbers?
Yep. You just take whatever they tell you the mean is, add a standard deviation. Notice because they gave it to them, right? Gave it to us right here. They gave us the mean was 100,
Oh, okay.
and they gave us the standard deviation. So you just add it 3 times. So you add 16.1, add 16.1 again, and then add it a third time, and that'll give us these 3 values over here.
Oh, okay, so you added it 3 times because it said that there was 3 standard deviations, is that why?
Mm-hmm.
Really?
Mm-hmm.
No.
Now, am I the only one that's hearing 3 voices when she
I'm
talks?
hearing it too.
Okay.
I heard it too.
I thought I stepped into Star
Yeah,
Trek or
me
something
too.
like that. It was somebody.
It tripped me out.
I'm sorry.
You're
No,
good.
I'm just trying to understand it because this whole diagram thing is, it just like threw me off.
Mm-hmm.
But if you, what she just asked, you're saying that because in Stevie's word problems, there's too much words and it'll throw you off. And
They
so,
can be. Mm-hmm. I
yeah,
agree.
so you're saying you take 100 and you add it 3 times, 16.1, 16.1, 16.1 to 100 because there's 3 standard deviations.
Mm-hmm. You got it.
Okay.
All of y'all got it. Like,
Ask me tomorrow and I probably won't know, but it's all right for now.
I don't think you get it, but there are 3 of you that's talking at the same time. And so it's real funny right now. So, all right. So that's the right side. And then for the left side, instead of adding, we're going to subtract 3 standard deviations. All right. So you subtract the 16.1 from 100, then subtract 16.1 again, then subtract 16.1 a third time to get the 3 values to the left of your mean. So it's 83.9, 67.8, and then 51.7. All right. And once again, those numbers are determined by whatever your mean and your standard deviations are. And your standard deviation, yeah. And your standard deviation is. What it be is? Anyway, whatever. Not an English major.
Will all the problems like that have like, say the number and then SB, so you know what the standard deviation is? It'll tell you what it is. You don't have to figure it out, right?
Yeah, and these type of problems, they're going to tell you what the mean and the standard deviations are.
Okay. All right, thank you.
Mhm. Now, I will say this though, now I just gave you guys a way that it's not like you have to calculate that standard deviation. If by some chance they give you a data set, don't forget you would go to easycalculation.com and just type it in and it'll just give it to you. I don't think they're going to give you that.
Amen for the website.
Oh yeah, most definitely. And you can do the same thing for the mean as well. If you do mean, easycalculation.com, they got that for the mean. I just know that normally, people just go ahead and calculate the mean. But let's say if you don't feel like doing it, or it's a data set that's very large, if you do mean easy calculation, that'll pop up for easycalculation.com as well. Type those data values in for to calculate the mean, it'll do it for you. So really, they're not really emphasizing, like I said, the formula usage, but really having something that's reliable that can calculate these things for you, and then the application. So yep.
And when we put it in the calculator site, will it still be least to greatest? You'll put the values in like that, or will they do that as well?
Now you don't have to do that for the mean. Anyway, it was the median. And I think I haven't done the median through easycalculation.com, but I'm pretty sure if you throw it in there, it's gonna do it for you. But it's worth checking out. You know, if you do median, I think when you do mean, median, and mode are all in that same web page. But it's worth checking out. But once again, when you talk about calculating your mean, you don't have to put those in order. It's your median that you have to put in order.
Right, and we would just use the site just like for the standard deviation and things of that sort.
Mm-hmm. Yep. All right, so we good right side, left side before we go back to the diagram?
Quick question, when we write, do we have to write this formula out when we're doing it like that?
No,
Left
that's
and
just
right side?
me giving y'all a visual of what's going
Okay.
on. Yep. However y'all do it in your scratch work, as long as y'all know what's going on, that's all that matters, you know. Yeah. So going here to the diagram, let me erase this. So remember I told you that these percentages do not change. Those are the same percentages that we had initially. But what's going to change are the numbers that's down bottom, and that's based on what we've been given, the information we've been given. Notice the median is in the middle. The median was 100. Now the right are those values that we had for the right side, and then on the left are those last three values that we found to be on the left side of our mean. And remember that represents 1 standard deviation out, 2 standard deviations out, and then 3 standard deviations out from the mean. Mm-hmm. Any problems before we go to A, B, and C?
I
All right.
just second to, can I copy that really quick?
Yep.
Okay.
And once
Are you
again,
reposting this lecture?
yeah, most definitely. I should have time. I don't think I have to make dinner. I think it's already made, but if I do, I'll knock it out after dinner and shoot this thing to you guys. Yeah.
No, I'm just saying like within the next couple of days. I didn't mean like tonight.
Oh yeah, most definitely. I'm gonna get it to you.
All right.
Yeah. Mm-hmm.
All right, thank you.
Yep.
Boy.
So once again, just re-emphasizing, these percentages are the same percentages from our first diagram. Those percentages will never change. These bottom numbers will change according to the information that's given.
Oh, okay.
Mm-hmm. All right. Are we good to go now? I know somebody asked me to wait for a second. Okay, I guess that means we're good. Now, A, remember I said that we didn't need these data values to do A. A was based on the empirical rule itself. So if I were to go back to the question, determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. So remember, that was this right here. You know, approximately 99.7% of the data is within 3 standard deviations of the mean. And so that's why that is just 99.7. That's all it asks about using the empirical rule. You know, what percentage of students do you expect to be within 3 standard deviations of the mean? 99.7. All right. Now the next one, B, determine the percentage of students who have scores between 67.8 and 132.2. So there are plenty of different ways you can play around with these numbers. That's why these percentages are important. If I want to know the percentage of students that we anticipate scoring between 67.8 and 132.2, 67.8 right here, 132.2 right here. So we would just add up the percentages in between those two data values. All right, and that will add up to give us 95%. So you can also state chances and, what's the chance, or who do, the number of students we expect to score between certain values. You can do 67.8, 83.9. You can, you can play around a lot with this. We had problems where they showed how you actually predict weather based on past events and past days, and say, during this time we expect, a certain percentage of rain, according to, percentage, empirical rule and all that stuff like that. So just, you can play around with different, once you have these numbers filled in, play around with percentages and everything. So just like the last one, C, it says determine the percentage of students who have scores above 132.2. So you go to 132.2 and you say above, you're talking about to the right of 132.2. So that's these two values. So that's why you add together 2.35 and 0.15, which would be 2.5% of the students we expect to score higher than that 132.2. All right. Questions on what we did here? Any questions? All right. Are we good? Let me go to the next thing. We straight. All right. I think we gotta do Z-scores. Don't copy that title yet. Just want to make sure my Z-scores are straight. Okay. Yep. And I believe we go to Yep. Okay, cool. Just making sure I'm on the right page as far as what I'm trying to do next. All right. So Z-scores. Still in 3.2. Remember we talking about one of the other part was Z-scores. So Z-scores, the distance a data value is from the mean in terms of standard deviations. So in the red is our general way of expressing or calculating the Z-score. It's going to be a data value minus the mean divided by the standard deviation. And so in the green and in the purple, I was just using the symbolism for the population versus the sample. So it doesn't matter which symbols you use, doesn't matter whether it's population or sample, it's always going to be what's in the red, your data value minus the mean divided by the standard deviation. Once again, those are just the symbols that you would use if you were population or if you had the sample, but they still represent the data value minus the mean divided by the standard deviation. All right.
What up?
Mm-hmm. Did you say go up or hold up?
Hold up.
Okay.
Oh, sorry.
So
Go
Yeah,
down.
can I see the population? It
Yeah.
was Z equals. Okay,
Yep, there
thank
go.
you.
Not a problem. So 2 statements about the Z-score, just in case Math Lab asks. Z-score is unitless and it has a mean of 0 and standard deviation of 1. So that's going to come more into play when we get into the application of Z-scores as we progress throughout the course. once we convert everything, you'll see that your z-score, your mean is in the middle, and it's going to be 0. And standard deviation will be based on 1 and everything. But I believe my math lab asked a question like, what's the mean, what's standard deviation of z-score? So 0 and 1 would be that. But it'll make more sense when we go to our z-score chart and all that stuff.
0. Yes.
Mhm. All right, now scroll up now. All right, so here it says determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and play in the American League, where the mean was 677.4. Sorry if I ran some of that stuff together. And SD, your standard deviation, was 51.7. The Rockies scored 755 and play in the National League, where the mean was 640 and standard deviation was 55.9. So give you a chance to write that down and we'll go from there. All right, scroll up some. So we want to determine whether the Angels or Rocky had a relatively better run producing season. So the reason why this is our numbers are a little different. One has a different average and standard deviation versus the others. If you don't watch baseball that much, you have the American League versus the National League. But American League do have a little bit of different rules than the National League, so it is worth looking at them separately. So just like before, you want to write down the given information. So the Angels had our data value, the run producing season of 7,730. 773. I can say it right. But the mean for the American League was 677.4, which is where they play. And then standard deviation 51.7. Now the Rockies, 755 is their run producing season. And the mean though for the National League is 640, standard deviation is 55.9. So I just wrote down all of the given information and gave it to the symbols. All right. Now we'll find the Z-score for each, respectively. So 773 minus 677.4 divided by 51.7 is 1.85. Anybody still in black? Anybody still missing the black? And then for the Rockies, 755 minus 640 divided by 55.9, 2.06. Now with your Z-scores, you will always round those to two decimal places. That will matter later on when we use our Z-score chart. You might as well get in the habit of it now. Z-scores will always be rounded to two decimals, I can't even get it out, to two decimal places. There you go. All right, talk about what that means in a second, just giving everybody a chance to write it down. All right, scroll up some. So green is just an interpretation of what these values mean, these Z-scores mean. So the Angels scored 1.85 standard deviations above the mean. So it is above the mean because the 1.85 is positive. If it was negative, then we would say below the mean. So the Rockies scored 2.06 standard deviations above the mean. So the fact that it's positive versus negative do mean something, does carry information. And so that means the Rockies had a better run producing year. All right, let's see. Don't believe we're doing percentiles. Make sure everybody's good before I go to the next page. Everybody straight? Like we're good. Okay. So 155. Yep, another one. Yep, we need this right here. Okay. So here's another example. And remember, the other part of this section was talking about what's unusual. So we're gonna use the z-score to determine whether something is unusual or not. So the mean daily temperature in San Francisco is 65 degrees Fahrenheit. Standard deviation is 8 degrees. On one day, the high temperature is 49 degrees. What is this temperature in standard units? And standard units is another way of referencing z-score. So that's why I wrote that in red. Then assuming the empirical rule applies, does this seem unusual? All right, scrolling up a little bit. So once again, we're going to take the given information and make sure we establish it. So our mean is 65, standard deviation is 8, data value is 49. We're talking about this day with a high temperature of 49. Want to know, is that unusual or not? So the first thing we do is convert it to a z-score. So that's what I did here. Data value minus the mean divided by standard deviation. So 49 minus 65 divided by 8 gives us negative 2.00.
We did the 49 minus 65 again.
We converted it to our standard units, the z-score. And so your z-score is always your data value. In other words, the value in question. The value that we have for this day is 49 degrees minus the mean divided by the standard deviation.
Okay.
Yep, that's your formula. All right, are we done with the black? Show up some.
So
Mhm.
do we always, is the z-score always the data value minus the mean over standard deviation?
Yep.
Okay, then what was, so when you were going over that earlier and giving us the formulas, that was labeled as general, and then you had population and sample.
I was just,
So
I'm sorry, go ahead.
how do we know when to use those different ones?
Well, I was telling you they were all the same. It's just that, yeah, they were all exactly the same. It's just that in the population, those would be the symbols used. Then for the sample, those would be the symbols used, but they all represent the same thing, which is the data value minus the mean divided by the standard deviation.
Oh, okay. All right. So that makes, all right. Got it. Thanks.
All right, yeah, no problem. Not a problem at all. Not a problem. Glad you asked. So according to the empirical rule, 95% of the data is between -2 and +2 standard deviations. This would be considered an unusual cold day. And I'm about to show you, got a little diagram, but everyone try not to go too far up. Give you guys a chance to copy. And so remember the -2 that we're talking about, we have -2 right here for our z-score. And then it's -2 right here from the empirical rule. So that's why I referenced -2. All right. So if I just had a regular just line graph to show what's unusual versus what's usual or ordinary, -2 and +2 on out. So you're talking about less than -2 and less than it, +2 and greater than it are considered unusual. And then everything in between -2 and +2 are considered ordinary or usual. And right here is just me saying it again, different way. Your z-score being equal to 2 or more, z-score being -2 or less, considered unusual. All right. Any problems? Any problems? Scroll up. I think that's it. Yep, that's it for 3.2. How many sections in chapter 3? 3, 3, 4. Skew distribution, median, IQR range. Hold on 1 second, guys. Trying to make sure. Measure the center. Some of the stuff we already did. Box plot summaries. Yep. Summary from skew distribution, median, IQR and range. Okay. And measure the center. What I did was just the outliers. Okay, so I'm comparing groups. Okay. All right, so we don't have much left as far as that's concerned. Okay, some of the stuff we already covered. Okay, so 3.3, summaries of skewed distributors or distributions, excuse me. We've already done the median and we've already done the range. And so we're going to talk about the IQR. Where it go? I know we're going to do it in 3.5. We want to talk about it before then. Compare measures of center. Okay. Yeah. Okay. So we'll talk about IQR on 3.5. But just so you know, you might want to, you can notate, you know, these 3 things. But we already, like I said, we already discussed median. It was just in a better flow where I had it. And same thing with the range. We're going to do IQR in 3.5. It just flows in those steps, and you'll see what I mean in a second. All right, so everybody done with copying that. So All right. Let me see. It is, might say, let me see. I will, I don't know, we'll see. Okay, so 3.4, comparing measures of center. I know y'all wondering what he keep talking about. Well, you know, it's a class, it's a one-day class, 1 day a week class. So I'm trying to gauge how much to hit y'all with and how much to pull back. You know what I mean? Like, not lecture too long, but at the same time, we still got stuff to talk about that, you know. So I'm trying to gauge it because I know at some point people just writing down words like so I get it. Trust me, I'm trying to be judicial in what I do and how I do it. So yeah. So in symmetric distribution, the mean and median are approximately the same. All right. In a right skewed distribution, the mean tends to be greater than the median. All right, just looking at something. Okay, yeah, that's cool. All right, in a left skewed distribution, the mean tends to be less than the median. All right, everybody done with that? All right, next thing we already talked about, being resistant to outliers. We already talked about that. All right, so when comparing groups, if any one group is strongly skewed or has outliers, it is usually best to compare the medians and IQR for all groups. So like I said, in the next section, we'll talk more how you calculate IQR.
Hey, Professor,
Yes.
is there a word after skewed in that the one comparing groups?
No, no. It says skewed. You talking right here?
Yeah, I
Yeah.
can't see.
Oh, okay. It says when comparing groups, if any one group is strongly skewed or has
Gotcha.
outliers, it is usually
Yeah.
best to compare the medians. Yeah. All right, guys, we are almost finished. Got something to show you out of 3-5, and then we'll be done.
And then you will post this after we're done tonight, or are you gonna do it like tomorrow or something?
I'm gonna try to do it tonight.
Okay, great.
Yeah, if I don't get it by tonight, most definitely by tomorrow.
Okay.
Mhm. Yep. Let me see. Can I scroll up? Everybody good? Yep. So now using box plots and displaying summaries. So just letting you type it, not type, but write up that title, and then we'll go ahead to the steps and all that. All right, so hold on, 3-4 is when I first talk about it. Okay, so 3-4, not 3-4, 3-5. When I first make sure we know what our start off with our quartiles. So it divides our data set into fourths. All right, so notice we have the minimum value, which is our smallest value, Q1, Q2, Q3, and then the maximum value. All right, so finding your quartiles. So those are your steps. First, you want to list your data values from least to greatest. Once again, don't forget this step. It's easy to forget, and a lot of people do it. So don't forget that first step, list your data values from least to greatest. Then we're going to find quartile 2 first. That's going to be the median of the whole data set. It's going to split your data into half. All right. Then we'll find Q1, which is the median of the first half of data. And then find Q3, which is the median of the second half of data. So IQR, which is your interquartile range. Let me write that a little better. It's the range of the middle 50% of your data set. And you will take Q3 minus Q1. So your quartiles are third quartile and your first quartile. Subtract them, that will give you your IQR.
I'm still writing number 4.
All right, not a problem. All right, can I scroll up? Everybody okay? All right, so we can also use the IQR. Let me do that better. To check for outliers. So outliers are very extreme values, and we talked about those already. Very, very large or very, very small values in comparison to the data set. So we can establish some fences. We can have an upper fence and a lower fence. Your upper fence will be Q3 plus 1.5 times your IQR. 1.5 is just a part of the formula. Or your lower fence, which is Q1 minus 1.5 times the IQR. So we'll talk about how to use those fences in a second. All right, let's scroll up. Of course, if I'm one or too high, let me know. All right, so in the green, if a data value is greater than the upper fence, then it is an outlier. If a data value is less than the lower fence, then it would be an outlier. So those are our fences. Those are our versus, you're just looking at a data set and say, oh, that value looks very, very large, or that value looks very, very small. This is actually setting a boundary and saying, okay, if something is greater than this, it's an outlier. Or if something is less than this number, then that's an outlier. So that's what these upper fences, this upper fence and this lower fence does for us.
I have a question, Professor.
Mhm. Yes.
Where does the 1.5 in the equation come from? Is that just a standard unit?
Yes. Now, where they got their standard from, I do not know. I have never looked it up. But yeah, it's just a part of the formula. It's a part of standard. So you will always use that 1.5. Yeah.
Okay, thank you.
Yeah, not a problem. All right. So we're going to use all this in an example. Just give you all the steps first. So just trying to make sure we're good before we go to that example. All right, still see a few copying. It's fine. All right. Nope, still see somebody copying. All right, are we good to go? All right, so your 5-number summary is going to be your minimum value, Q1, Q2, Q3, and then that maximum value. So you just use a modified box plot. All right. Looking for one thing, I don't see it. Okay, yep, there we go. I was looking for that. Okay, so here with box plots, you see it's a graphical tool used to compare groups of data. All right, it consists of a box with lines that extend to the minimum and maximum values that are not outliers. So you see how that works in a second. These lines are called whiskers. Outliers are represented by an asterisk. Let's scroll up to right here. All right, so that's how generically our box plot will look. You have your box that has 3 lines in it, you know, the ends, and then in the middle, that's Q1, Q2, and Q3. Your whiskers will extend out to the maximum and minimum value that are not outliers. And then we can represent any outliers as asterisks.
Professor, what are those? Are those two like stars or asterisks, and does it say outliers underneath it? You're on mute.
Yes, outliers. Right there.
Okay, thank you.
Yeah, yeah, not a problem. All right, we ready to scroll up, try this thing out? All right. So give the 5-number summary and then sketch the box plot. So in the red, just saying that the data set is not always written from least to greatest. Make sure that this is the case before you move forward. I don't know if you noticed, but that's something I keep trying to make sure I, emphasize. Don't forget to write your data values from least to greatest. I scroll up. All right. All right, so when we get to the whole data set, like I said, I'm giving people a chance to write, of course, but when you get to the whole data set, you see I've already listed it from least to greatest. And also what I normally do is I count the number of data values that I have, and I automatically just write them in halves. So in other words, if I had 10 data value, well, let's say 100, or just something crazy. If I had 100, then I would write 50, then I would write the other 50. In other words, I would break it in half. To help me with finding my median. So here we have 21 data values altogether. So I do 20. I put 1 in the middle because that's my middle value. Then I said 20. We have 21 data values. So I do 10 first, put 1 in the middle, then I do the other 10. And that adds up to my 21. And it helps me to break up my data values and splits up my first half of data with my second half of data and all that. So now you don't have to do that. It's up to you, but that's just what I did with my data set. That's how I normally list them from least to greatest. Break it up in the first half and second half. If I have an odd number, go ahead and put that one in the middle as my median. So, not sure how far we are. Is that good? So that's my data set right there. First step, write your data values from least to greatest. So that's 1995, and that is the decimal in there for all of them. So 1995, 2325, 2332, 2555, 2583, 2628, 2858, 2872, 3018, 3035. Then I have 3095, 3213, 3323, 3353, 3668, 3705, 3743, 4142, 4247, 4915, 5463. So I did a little color coding as well. You'll see in a second how they match up. But those are my data values, 21 data values altogether. All right, you ready to go up a little? So, as I mentioned, the first step is to write your data values from least to greatest. Second step is to find Q2. Now, Your Q2 is the middle value of the whole data set. That's the median of the whole data set. And since we had an odd number of data values, that means we did have a legit middle value, which is 30.95. So no calculation needed. We just picked out the middle value, which was 30.95. Okay.
So that
Now,
last number in that first half of the data set, that's 30.95, not 30.35.
well, this is 30.35, but right here is 30.95.
Oh, okay. I see what you did. Okay, got it.
Yeah. So just make sure we clear. I think she knows what I did now, but just make sure nobody else has a question. So I have 10 data values up here, 10 data values up here, and then one in the middle, and that adds up to my 21 data values. I split it up into half the middle value, and then the other half.
How'd you find the 30.95 again?
It was a part of the data set. All of these were given. But when I listed it from least to greatest, I listed it in that order so that I can have a middle. So, my middle value is like really
21st
evident.
number, I got you.
Yeah, it was really evident what my middle value is. So I just wrote it that way. Like I said, you guys don't have to write it this way. I just wrote it this way so that my middle value was completely evident. I didn't have to go searching for it. So I just wrote it. That's why I wrote it this way. So if I were to rewrite this with, just removing these circles, that's how I wrote it. Everybody good, everybody straight. So once again, just reemphasizing, I did no calculation for these values. All these values were given. I just wrote them in order. Just wrote them in order from least to greatest. So sorry if I, didn't make that evident. All right. So next we want to find Q1. Now Q2 is the middle value of the whole data set. Q1 is going to be the middle value or the median of your first half of data. So we're just looking at this first half of data. Now there are 10 values in my first half of data. So it means there is not a legit middle value. So it means we need to take the 2, which is 25.83, 26.28, take the 2 data values. Yep, add them together and divide by 2. That's what we did here.
Sorry, I thought I was muted.
You good.
I was talking to myself.
All right. And then we'll do the same thing for Q3 in our fourth step. Q3 is going to be the median of the second half of data. So looking at what we have here, once again, with 10 data values in our second half of data, don't have a legit middle value. So we take the 2 middle values, 37.05, 37.43, add them together, divide by 2, that gives us 37.24. So once again, all 3 of those values, those quartiles, they are medians. They're just middle values. Q2 is the middle value of the whole data set. Q1 is the middle value of the first half of data. Q3 is the middle value of the second half of data. All right. Step 5, we can calculate our IQR. I'm trying to get my, that's the wrong color. So we're going to find IQR by subtracting Q3 and Q1. That gives us 11.18. All right, step 6. We go ahead and establish our fences. I forgot whether your book called it the left limit or right limit. But if they do, it's called the same thing. Left limit, or in other words, our lower fence. And then the right limit, it's the same thing as our upper fence, just another way of calling it, another terminology, but it's the same calculation. So Q1 minus 1.5 times the IQR. So that's 26.06 minus 1.5 times that 11.18. That gives us 9.29. Then our upper fence, Q3 plus 1.5 times the IQR, 37.24. 1.5 times 11.18, that gives me 54.01. Almost finished, almost finished. So in the red, just reestablishing or just reiterating what these fences mean to us. So if a value is less than the lower fence or greater than the upper fence, it is considered an outlier. So last step, we determine if we do have any outliers or not. We go ahead and look at these fences and compare it to our data set. And then we find out that 54.63 is an outlier because it's greater than 54.01. So we didn't have anything less than that 9.29, so we're okay on that side. But this 54.63 is greater than this upper fence. Any questions before we close this out? All right, so after we've done those 7 steps, we have enough information for the 5-number summary and our box plot now. So, is everybody done with the blue? All right, so that's our 5-number summary. Now, notice that's the minimum, Q1, Q2, Q3, and then the maximum. This has nothing to do with whether they are outliers or not. Just what's your smallest value, what's your largest value. So don't get that confused with the box plot and outliers and everything. It doesn't say maximum instead of being outlier or anything like that. It's just what's your largest value, what's your smallest value. Those will be, 1 and 5. So just throwing that out there. Those were our largest, smallest values, Q1, Q2, and Q3. That's your 5-number summary. And then your box plot will use those same values. In this fashion, let me see if I can magnify. But when it comes to your box plot extending out to an outlier, then it will not do so because in your box plot, your whisker is going to extend out to the largest and smallest values that are not outlier. And this should be a little more legible. Like that better. So this was the next value up past, after that outlier. All right. questions on anything that we've done? Mhm. Mhm. So, like I said, those are your steps, 7 steps. Once you have those steps down, then you can just go ahead and, write down what your 5 numbers are. And then, like I said, establish your best plot. So any questions before we move off this and get ready to close out? All right. Well, if you're good, you don't have any questions. I know some people still may be writing down. That's fine. Take your time. But if you are good, you don't have any questions, then I will see you next week. Always feel free to email me if you have any questions. You do not have to wait until next Tuesday to ask me questions. If you have any questions, or if you want to establish a moment, like your classmate even mentioned, that we can meet up and talk about some things, feel free to do so. But I will ask you this: if you want to meet with me, that's great. Make sure you come with your questions already lined up. You know what I mean? So in other words, I had a problem with 1.1 number 2, like, you know what I mean? So that we can make proper use of our time. And, we're not fishing around for questions or fishing around for something that really, is a problem or issue. But if you already have your questions lined up, then we can go ahead and just hit them and then move on to the next thing. So that's all I ask, other than that, whatever time works best for our schedules, we can make it happen. All right. Anything else before we close? Everybody good?
No question.
Do you have any
Question.
homework assigned?
Oh, well, I got like 5 people at the same time. Give me. All right, one at a time. What we got?
Do we have any homework assigned?
So it's now, as far as your homework is concerned, I'm glad you said that. So as far as your homework is concerned, we just did chapter 3, all of chapter 3. Now all of the homeworks aren't created equal. Like when I looked at 3, 4, I think. No, let me go here. I think it was 3, 4. Yeah, you know how 3, 4 was short? That's because the homework was a short assignment. I think it was only like 6 problems, and it was definition, pretty much asking you stuff about symmetric distribution and stuff. So yeah, you have 3, 1 through 3, 5 that we covered today. And so, I would say just get in there, start looking at chapter 3 stuff and see if you have any questions on anything. Yep,
Okay, thank you.
yep. Not a problem.
Okay, and
What else
so
we got?
you said when you get a chance, you will send out the recap like you did last time to each one of us, or you'll put it on Canvas. Okay.
Yeah, so what I'll do is I'll make the YouTube link and then I'll shoot it to you guys all at one time. So I'll try to do that tonight before I hit the bed. Yep.
Okay, thank you.
Yep, not a problem. All right. Anything else? I know Mr. Corey has something.
Yeah. I'm trying to figure out how you got 49.17 as the max. On the
Okay.
box plot.
Oh,
On
yeah,
the
yeah,
box
yeah.
plot.
Yeah, let me go back. Somebody else said something in the chat. Let's do that. Okay, cool. Somebody said something real quick, sir. I'll get to yours. I'll be in class. I'll be traveling back to Dade, Miami. Oh wow, sorry to hear that. Yeah, that's not a problem at all. Not a problem at all. I didn't tell y'all I'm getting my second vaccination shot at 4 o'clock on our class day, and I don't know how it's gonna mess me up. I don't know if that's gonna mess me up. I heard people get sick, so if I get sick,
the next day might be sick.
I didn't
next
get
day.
no.
I
Call
got
out,
hor-
yeah, just call out.
No,
I got horribly sick. It was horrible.
Yeah, so I felt bad the next day.
The next day.
All I say is you need to rest and hydrate.
Water,
lots
of water. Okay, I hear y'all.
I had
Okay.
no symptoms. So
I had nothing. I was good.
Really?
right. I guess it
Yeah.
depends on your immune system. Yeah, I
Okay.
didn't have any problems at all.
Oh, okay. Well, I hope I can have that same testimony. All right. I was just giving y'all a heads up because if I'm out, that would be the reason. So
Your arm might be a little bit sore too.
Yeah, other than that.
Okay.
But,
Yeah.
For at least a couple days.
Okay.
Yeah.
Cool.
Rub it with alcohol.
We're hoping that's
Move it.
all it is.
Other than that, I was good.
All right, cool. Hopefully that's all it is. So yeah, so you're talking about this one, right, sir?
I'm trying to figure out how you got 49.17 as the max.
So that goes back to, first of all, box plot. Remember that your whiskers are not going to extend to anything that is considered an outlier. All right, so that's the first thing. So
Okay.
now when we go to our data set, these were our last two values. Now remember, we found out that this was an outlier.
The
So
54.63.
yeah. So remember right here, 54.63 is greater than that upper fence, so it is an outlier. So our whisker cannot extend to the 54.63, so it has to extend to the next value up, which is that
Oh,
49.17.
next value down, you mean?
Well, yeah. Mhm,
Okay, so that would be your max. Okay.
mhm.
All right, I got it.
All right,
I got it. Thank you.
cool, not a problem. Appreciate the advice in the chat. Anything else, anybody else before we close? Everybody good?
Quick question. So the best way to email you is through Canvas, correct? Or-
Either or, Canvas or vtucker@tcc.edu. Both of them go to the same email address,
Oh,
same account. Yep.
okay, thank you.
All right,
You
not a
said
problem.
Do you happen to get my last email?
When did you send it? Was it
I've
a
slept
while?
since then. It's been like a day or two.
That's a good way to say it. I've slept since then.
It's been like a day or two. It was about the reps. For I'm the one with the wonky access code. I got access to the other one because Pearson gave me a code because Barnes and Noble gave me the wrong code.
Okay.
So they gave me the free one to replace it, and now they're
Gotcha.
telling me they won't pay for another one because you changed the cell.
I think I remember this story. I thought I responded to you. Can you resend that to me? 'Cause I
Yeah,
don't see it.
I'll resend you the same email, but that's
Yeah.
the whole situation basically.
Yeah.
Is they told me I should have gone through Barnes and Noble to get a refund, but they never told me to.
Gotcha. We'll make sure you're straight.
All right, cool. I'm in the 14-day free thing right
Mhm.
now, so
Mhm.
I have
Yeah.
access at least for right now.
Okay, cool. Yeah. As soon as you get that to me, I'll forward it to our rep, and then she should be able to make sure you're good.
All right, cool. Thank you.
All right, thank you. All right, anybody else?
Can you say your email one more time?
Yes, matter of fact, I'll write it. Just vtucker@tcc.edu.
All right, thank you.
Not a problem. All right, anybody else? Everybody good? All right, see shit here shaking. Sorry for holding y'all so long, man. Look, I'm supposed to have y'all till like 10 o'clock, right? Isn't that what it is?
Yeah, it's
No,
all good, man.
I'm just messing with you.
It's all good.
Yes, sir. So, like I said, check this stuff out. If you have any questions, hit me up, let me know. Other
Alrighty.
than that, you guys have a great week. Be safe, and I'll see you next Tuesday.
You too.
You too. Good luck with
Thank
your
you, you
shot.
too.
Thank you. Appreciate it. Take care.
Professor, I have one thing, and it's
Okay.
just me being picky, and I'm sorry.
It's okay. What's up?
It's when you wrote down the median separates the data set into halves. You put HALFS. It's HALVES, halves.
Well, see, my major is math.
I'm sorry.
No, look, I have no problem with somebody correcting me on English. I hold true to that. My major is math. Yeah, thanks. I appreciate it. I'm gonna go back and check that out.
I was just looking at it. I'm like, oh, I'm OCD, and this is like, not, no.
I thought it was so
no.
bad when you said I hate to be picky. I'm like, oh no, what did I do? So no, I'll take that L. I'm good.
And the other thing, and I can't say anything because I have horrible handwriting, you should have gone into medicine with your handwriting.
You see, I tried this. Sometimes I be trying to rewrite it to make it look better. I'm like, oh, I can't believe nobody said nothing the first time. So
I'm sorry. I tried holding off on it, and I'm like, he really should have gone into medicine. He would have made a great doctor because they can't write for nothing.
well, I appreciate it.
All right. Have a great night.
Thanks, you do the same. Y'all take care.
Thank you.